So for today's lesson, we're going to talk about histograms, and we'll do some construction and analyzation of them. But before we do that, we want to talk about a couple different vocab words. So one of them is qualitative data, and that's descriptions of data that uses categories, such as people and locations. Another type of data is quantitative, and that's descriptions of data using numbers, such as quantity, height, or age. So if you identify the following as either qualitative or quantitative, presidents and their places of birth has nothing to do with numbers. It has to do everything with categories. So this would be qualitative. It's going to put QUAL. The next one, percent of people living in poverty. Well, percent deals with numbers, so that would be quantitative. Again, I'm just abbreviating these for now, but you can write them all out. This one should be, no-brainer. Talks about number of votes. Well, number is number. So this is going to be a quantitative type of data. And then favorite places for a vacation. No numbers involved, just names of places. That's qualitative. There's two other types of data that we need to discuss, univariate data and bivariate data, and the prefixes should tell you what they're all about. Uni meaning one, bi meaning two. This gets tricky for some kids, but it really shouldn't. So if we're dealing with univariate versus bivariate, if you know for sure that you're comparing two things, and there's usually a key word in the sentence which will tell you whether it's a comparison or not, that would be your bivariate. So this first one, the 3-year rate of return for various mutual funds. You're looking at a whole bunch of funds, but looking at just their 3-year rate of return. So it's only one set of data that you're dealing with. This would be univariate. Again, I'm doing some abbreviation here. Number 2, relationships between per capita gross domestic product and the life expectancy of residents of a country. Well, that's bivariate. That word and should really be key to letting you know that we're talking about two different things. 3, gestation period of an animal and the animal's life expectancy. There's that word and again. We're talking about gestation period versus life expectancy. That's going to be your bi. The pulse rate of 8 randomly selected individuals after jogging for 1 minute. Well, we're looking at 8 different people, but all we're looking at is just their pulse rate. So that would be considered univariate data. Okay, so where we get to next is frequency tables. So that's a table that shows how often each item, number, or I'm not sure what that next word is, of numbers occurs in the set of data. So here's the example. The ages of 15 children at the park yesterday are as follows. They give you 15 different ages. The data can be displayed as a frequency distribution. So the idea is we need to have some intervals, and intervals are equal, ranges between the data sets. The tally, those tick marks, and then the frequency, the total number of people that are in that particular interval. Well, if you look at the youngest child is 1. If you look at the oldest child is 14. Well, I need to split up those ages in 3 equal intervals, but 14 is not divisible by 3. So I'm looking for the next smallest number above 14 that is divisible by 3, and that would be 15. So I need to have equal intervals. So if I take 15 divided by 3, and the 15 really means the age, ages of 15, I can have intervals that would be 1 to 5-year-olds, 6 to 10-year-olds, and 11 to 15-year-olds. It's okay that we don't have a 15-year-old, but we need to have the ages in equal intervals. It's really important. It might even be worth writing the word here, equal intervals. So then what you need to do is do tally marks for those kids. So in other words, I've got a 5-year-old would go there, a 7 would go here, 6, 8, 9, 5, 13, 2, 1, 6, 5. Whoopsie, that should have been like this. 14, 10, 5, 9. So if we add up the frequencies, there were 6 children between the ages of 1 and 5, there were 7 children between the ages of 6 and 10, and there were 2 children between the ages of 11 and 15. And that does, in fact, add up to 15 kids total, right? If I look at my frequencies, that gives me a total of 15, and I did, in fact, have 15 kids at the park. That's just a good check. So we're going to take this information, we're going to display it on a histogram. So a histogram is a frequency distribution for continuous quantitative data. The horizontal axis is a number line that displays the data in equal intervals, and the vertical axis will be the frequency. The frequency of each bar is shown on the vertical axis. You need to always make sure that you title and label your axes. So the title of this one maybe would be Children at the park. Well, the x-axis we know is going to be showing, the horizontal axis is going to show the number in equal intervals. So the bottom really is all about the ages of the kids. And then on the left-hand side, it's going to be the number of kids for that age. So that's going to be the number of kids. Well, for the equal intervals, we know that there were 3. So I'm going to take my x-axis and split it up into 3 what looks to me like equal intervals. And these would be all my kids that were between 1 and 5 years old. These would be my 6 to 10 years old. These would be my 11 to 15-year-olds. I know that my highest frequency was 7, so there's no reason why I can't just count by ones. 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Now what has to happen here is my histogram, the bars must touch because the intervals are equal. So if I remember correctly, there were 6 kids, I believe. Let me just double check real fast. I think that there were 6 kids that were, come on. Yeah, so 6 kids. All right. I'm trying to get back to that page. Here we go. So there were 6 children that were between the ages of 1 and 5. There were 7 children between the ages of 6 and 10. And there were 2 children between the ages of 11 and 15. Some people shade in their bars, some people don't. What I like to do is just kind of put the frequency inside those bars in case there's any confusion or above them. But I know that in this bar there were 6 children, in this bar there were 7, and in this bar there were 2. So that's creating your histograms. You should be able to analyze them as well, answer some questions, whether it's from the histogram or from the frequency distribution chart. But how many kids are between the ages of 6 and 15? Well, that's going to be looking at the kids on this chart that were the 7 and the 2, which means I'm going to have 9 children between the ages of 6 and 15. And then how many more kids were between the ages of 1 and 5, then 11 to 15? And that's going to be 6 minus 2, or 4 of those kids. All right, so you should be able to look at either your histogram to answer some questions, to analyze the data, or you should be able to look at your charts. And that's it. Good luck on the homework.